today's lecture we will continue talking about MIMO systems, multiple input, multiple output. In the previous lecture, we talked about a special case for MIMO, which is spatial multiplexing. Spatial multiplexing, we discussed the transmitter, how you can build the transmitter, and we discussed the equalizers of the receiver, and we mentioned maybe 6 or 7 types of equalizers. So, in the second use case, we will use space-time clock coding. The third use case will be beamforming for MIMO. Let's say these are MIMO use cases, and after beamforming, we will use MIMO for providing security, and after this, we will use MIMO for removing interference. Remove interference. So we already talked about this, we understand it, we learned the transmitter structure, the receiver structure, the different types of equalizers we can use. But today we will talk about a special topic called space-time clock coding, and we will start with something we call Alamouti coding. So what's Alamouti coding? In Alamouti coding, the main purpose is to try to exploit the diversity in the channel in order to improve the bit error rate at the receiver side. So instead of improving the data rate using spatial multiplexing data rate, here we want to improve what? The bit error rate, the reliability performance. And this is done using a matrix structure at the transmitter. So when you want to transmit your data, let's assume you have data coming in here, zeros and ones. You modulate them using QAM, 40 QAM, 16 QAM, whatever. And the output of the modulator is going to be like series of symbols. X1, X2, X3, X4, and so on and so forth. So in Alamouti coding, when you want to use Alamouti coding, you take 2 symbols by 2 symbols, assume Alamouti coding for the case where you have 2 transmit antenna at the transmitter and one receive antenna. So in this case, you have 2 antennas at the transmitter, antenna 1, antenna 2, and you send X1 from antenna 1 and X2 from antenna 2, and then what you do, you also send X2 conjugate multiplied by minus from antenna 2, and here X1 conjugate. This is time, and this is frequency space. So this is time slot number 1, this is time slot number 2. Slot 1, slot 2. So you have also here the receiver, and this is how the transmission will look like, where you have the channel H1 from antenna 1 and the receiver, and the channel H2 from antenna 2 and the receiver. So the receiver will get a signal called Y, and the question here, once the receiver receives Y, the job will be to detect X1 and X2, what are their values. How can we do this? this mathematically. This is what we will be explaining here.